Okay, I'm going to recall how to graph the cosecant function and the secant function. I'm going to explain it a little bit more thoroughly than I might have when we were first going over these parent functions. So cosecant of theta comes from 1 over the sine of theta. So it's the reciprocal function of the sine of theta. First thing I'm going to do is I'm going to plot the critical values for the sine function. So the sine function, 2 pi would be right about there. It's just a little bit smaller of a pen. So that would be about 2 pi right there. And this would be about 2 pi negative. So the sine function starts at the midline, ends at the midline, halfway through is at the midline. And then when theta is pi over 2, we have a maximum of positive 1. And when theta is 3 pi over 2, we have a minimum of negative 1. Then I'm going to continue the pattern so that I have all these critical points plotted. I'm going to even highlight the midline so that we can see where our graph, where our sine curve would cross through that midline. And everywhere that it would cross through the midline, I'm going to draw vertical asymptotes. Now it's the reciprocal function, so here's your sine curve. So the reciprocal function, I'm going to plot this in red so we could tell the difference between the graphs. The reciprocal function, when sine of theta, it gives me an output of 1. I'm going to have 1 over 1. Right? When the sine of theta gives me an output of 0, I have 1 over 0, which is undefined, which is your vertical asymptote. Well, somewhere between this 0 output and this 1 output, I've got 1/2. When I get a 1/2 out for the sine function, 1 over 1/2 is 2. And somewhere between this 0 and this 1, I've got an output of maybe 1/3, which is down here. And the reciprocal of 1/3 is 3 over 1. And the same thing happens on the right side, approaching that vertical asymptote from the left. And that's how you get your U-looking shaped curve. So you can see that this curve touches the maximum value and bounces back up. And what's going to happen here is that all the reciprocals of these blue dots are going to form these red dots. And the same is true on the right. And that's why you end up with this U-shaped curve again. So at all the maximums, you've got these U-shaped curves opening up, and at all the minimums, you have the U-shaped curve opening down. So the domain for your sine curve is negative infinity to positive infinity. Your range goes from -1 to +1. That's for the blue curve, which is your sine curve. For the cosecant curve, the domain is a little bit different. The domain is all real numbers except for your pi values. So theta cannot equal, I'm going to call it n pi. N pi, where n is an integer. So it's all the values except for your pi values. And your range, this is the more important part that I wanted to get to. your range has all the outputs from negative infinity to negative 1 and all the outputs from positive 1 to infinity. So let me show you with the highlighter. Negative infinity to negative 1, and then positive 1 to positive infinity. So you will never, ever, ever have ratios for the cosecant curve that are between negative 1 and positive 1. That just won't happen. The secant graph comes from your cosine curve. So cosine starts at the maximum, ends at the maximum. Halfway between it's at the minimum. And then halfway between the minimums and the maximums, we have our midlines. So here's our cosine curve. And everywhere our cosine curve crosses through the midline, we've got asymptotes. And we've got our U's opening up, our U's opening down. Opening up from the maximums and opening down from the minimums. And as you can see, in between negative 1 and positive 1 again, you'll never have any outputs for secant. So that's your parent functions for cosecant and secant.